Part E is the iron/iron thiocyanate equilibrium. It begins as Fe3 plus SCN minus into FeCN2 plus, all aqueous solutions. Originally, the two reactants are both clear and their product is red. The reaction is exothermic, so heat can be written over here as a product. When the heat is increased, it'll cause a shift left in the reaction, thus the orange-reddish color produced in the result of the heat being introduced. When the concentration of Fe is increased, it will cause a right shift in the equilibrium equation. Since Fe is increasing, it will cause a even darker red, and it's increasing on the left side, causing an increase in products. When KSCN is increased, it will also cause a right shift because the reactants are increasing. It will cause an increase in products. The resulting solution is also a very dark red. When AgNO3 is introduced into the equation, it takes place of the iron originally up here. This would cause this result to be AgSCN and would cause the iron to remain aqueous, thus the cloudy white resulting solution. Part A is CH3COOH aqueous into CH3COO minus aqueous plus H plus aqueous. Sodium acetate was added to the equation, which would dissociate into CH3COO minus aqueous, causing an increase in the concentration of the products here on the right side, which would cause a shift left towards the reactants, which is why the original pH was 4. It would cause the solution to become more basic, and it increases to 6. This is because there would be less hydrogen in the water and more CH3COOH. Part B is the chromate/dichromate equilibrium. CrO4 is yellow and Cr2O7 is orange. The original color is a light orange, signifying a proportional mixture of the two substances. First HCl is added, causing a darker orange to appear in the solution. HCl is a strong acid, which would take away from the H2 over here and create H3O. This would cause there to be less H2O to be formed to perform the reverse reaction. So H2O would decrease, and that would cause an equilibrium shift to the right, so more orange appearing, thus the darker orange color of the mixture. When NaOH is added to the solution, NaOH reacts with the H3O to form H2O. And so there would be more H2O in the solution than what was taken away from HCl. This would revert back to the original equation. The HCl and NaOH are more balancing each other out. When the original equation is taken and just added NaOH, the equation, the NaOH is a strong base and would bond with the hydrogens on this side, forming H2O. This would cause a decrease on this side, decrease on the left side, causing an equilibrium shift to the left, there would be less of the hydrogen present in the reaction, causing a shift to the left. Then when HCl is added again, plus HCl, it would work to cancel out the NaOH as the NaOH cancel out the HCl in the previous section. It would cause the color again to return to the original orange mixture of seen in this reaction.